Welcome to The Explainer. Today, we're taking a really fascinating look at thoracic anatomy to completely master the superior mediastinum. Now, if you've ever looked at the human body and just felt totally overwhelmed by all the interconnected parts, well, you're definitely in the right place. In this explainer, we're going to take one of the most incredibly packed, complex spaces in your entire body and break it down into really simple, easy-to-understand systems. So, let me ask you something to start us off. What exactly lies in that tiny piece of real estate right behind your breastbone, right there between your lungs? I mean, we all know the heart is down there, sure, but what about the area just above it? Because honestly, this specific space is absolutely critical to your survival. Well, think of it like this. The superior mediastinum is essentially the human body's ultimate transit hub. It is a biological grand central station. Literally every major highway of blood, every single crucial transit tunnel for air and food, and all these highly complex communication wires, they all have to pass through this exact central partition. We're talking about the space that extends from the top opening of your rib cage, which is called the superior thoracic aperture, straight down to an imaginary line called the transverse thoracic plane. All right, let's dive right into Section 1, the body's grand central station. To make this kind of a breeze to visualize, let's just build the physical walls of our station first. The superior mediastinum is contained by some very clear borders. Superiorly, so the roof, is that superior thoracic aperture, basically the opening right at the base of your neck. Inferiorly, the floor is that transverse thoracic plane we just mentioned. Anteriorly, meaning the front wall, is the manubrium, which is just the top part of your sternum. And posteriorly, the back wall, that consists of your first 4 thoracic vertebrae, T1 through T4. Moving right along to Section 2, the great blood vessels. Okay, let's look at how the body's venous plumbing actually comes together. Right behind your collarbones, you've got the internal jugular veins coming down from the head and the subclavian veins coming in from the arms. They merge together to form the brachiocephalic veins. Now, notice how the left brachiocephalic vein is actually way longer. It literally has to cross all the way over the midline, tucking behind the sternum, just to join its partner over on the right side. And where does all that blood go? Well, they merge and form the superior vena cava, or SVC. You can think of this as the massive vertical drain for your entire upper body. It's a really short but incredibly large diameter vein located on the right side of the superior mediastinum. And the key thing to note here is that it descends vertically and ends exactly at the lower border of the right third costal cartilage. That is the exact drop-off point where it dumps all that deoxygenated blood directly into the right atrium of the heart so it can be pumped out to the lungs. But what about the blood leaving the heart? Enter the body's absolute largest blood vessel, the aorta. Specifically, we're looking at the aortic arch. Emerging directly from the heart, the aorta shoots up, and then it does this dramatic curve backward and to the left, right over the airway. This creates a really distinct arch shape that is entirely contained within the superior mediastinum. The absolutely crucial point here is that this arch is in charge of distributing fresh, oxygen-rich blood. Think of these as 3 major highway exits just popping right off the top of the arch, going from right to left. First, you have the brachiocephalic trunk, supplying the right side of the head, neck, and right arm. Second is the left common carotid artery, heading straight up to supply the left side of the head and neck. And third is the left subclavian artery, curving out just below the collarbone to supply the left arm. Let's shift gears to Section 3, airway and digestive tubes. So we've got the plumbing, now let's talk about the central transit tunnels, starting with the airway. The trachea, which you probably know as the windpipe, is a flexible tube held open by about 15 to 20 C-shaped cartilages. This design is brilliant because it ensures your airway literally never collapses. Tracing it downward, it travels right behind the sternum and ends at a ridge called the carina. Right around the level of the T5 vertebra, it splits into your right and left main bronchi to feed the lungs. Now this brings us to a really helpful comparison. The trachea and the esophagus are these 2 parallel tubes, but they are built completely differently. The trachea sits up front, anteriorly, transporting air, and as we said, it's rigidly held open by cartilage. But right behind it sits the esophagus, located posteriorly. It transports your food and liquid, and unlike that rigid trachea, the esophagus is a highly flexible muscular tube. The thoracic part of the esophagus is about 10 inches long in total, and it basically sneaks deep behind the trachea and the heart. It operates using peristaltic contractions. Essentially, these are involuntary muscular waves that actively push your food down through this super busy thoracic space on its long journey to the stomach. Now, here is where it gets absolutely fascinating. We have the plumbing and we have the transit tunnels, but what actually controls all of this? Obviously, we need communication wires. Which brings us to Section 4, the vital nerve network. Hidden away among all these massive tubes and vessels is an incredibly dense network of nerves, specifically the vagus and phrenic nerves. And there's an amazing anatomical surprise here that is just wild. Notice the left vagus nerve coming down? Well, it gives off a tiny branch called the left recurrent laryngeal nerve. This nerve literally loops all the way down, tucks completely underneath the aortic arch, and then travels all the way back up the neck just to control your voice box. I mean, it's a bizarre and totally fascinating anatomical detour built right into your chest. Let's make sure we contrast these two major nerve systems so you never mix them up. The phrenic nerves originate from your cervical spine, C3 to C5. You can think of the phrenic nerve as a physical power cord. Its main job is to provide motor function to your diaphragm so you can literally physically breathe. On the right, we have the vagus nerves, cranial nerve 10. Think of this one as your body's high-speed internet cable. It provides unconscious, parasympathetic control to your heart rate, your lungs, and even your gut.
Okay, so we've covered the blood, the air, the food, and the electricity. But there's one final, and honestly often misunderstood system in this space: the hidden drainage system of the thorax.
Let's explore Section 5, the lymphatic highway. And that brings us to the thoracic duct, which is actually the largest lymphatic vessel in the entire human body. It ascends right up through the superior mediastinum, neatly tucked between the esophagus and the pleura of the left lung. And the brilliant part is where it ends, at the top. It basically drains all that collected lymphatic fluid back into your bloodstream exactly at the junction where the left internal jugular and left subclavian veins meet. It's just a perfectly designed recycling system. Let's wrap things up with Section 6, summary and key takeaways. So we've seen how all these incredibly complex systems fit together like a giant 3D puzzle. Let's do a rapid review of the core takeaways to really solidify your understanding of this biological grand central station. First, the superior mediastinum is that central hub bordered posteriorly by vertebrae T1 through T4. Second, your major venous drainage, those brachiocephalic veins and the superior vena cava, they sit up front, anteriorly. Third, tucked right behind them, is the massive aortic arch, curving backward, sending 3 vital branches to your head and arms. And finally, skillfully navigating around that central airway and food tubes are your vital phrenic and vagus communication nerves. You know, by visualizing these structures as interconnected systems, thoracic anatomy suddenly makes a whole lot more sense, doesn't it? If you found this visual breakdown helpful, please subscribe for more simple medical explainers. I'll leave you with this final thought. Given how unbelievably tightly packed the superior mediastinum is, which anatomical structure in the chest surprises you the most? Let me know below in the comments. And hey, tell me what body system you'd like us to simplify in our next explainer. Keep learning, and I will see you next time.